So these are a series of networking questions to help you with your understanding, and I wanted to go through these because quite often you have quite a few networking questions that will test you on your understanding of whether or not you know how the protocols work, whether or not you know how the different layers work. So the first thing says computer networks can be wired or wireless. State one wireless method used to connect devices on a personal area network. Generally speaking, personal area networks are wireless, okay? So realistically speaking there, you're going to be looking for technologies such as Bluetooth, infrared, you might even have near field, you know, NFC, you know, like where you have, say it again? Like contactless, that sort of thing. But personal area networks are your personal devices. So some answers you could have had here are Bluetooth. We're going to go for infrared. A wireless USB dongle. You might even have NFC, which is near field communication. Generally speaking, I would just stick to the Bluetooth one because that's generally, think about it, where you've shared your internet connection from your phone, tethering it, that sort of thing. That's the best way to remember personal area networks. Now, what is a computer network? Now, we should have got this, all right? You get 1 point for saying two or more computers. So that's 1 point, all right? Connected together. So two or more computers connected together. That's where you getting your marks from there. Or you could say, some of you may have said that can communicate with each other. You always need to acknowledge though that there are multiple computers connected together in order to get at least one of the marks. It is not a network unless there are two devices connected together, okay? Now, MAC address filtering. 2 marks available here, right? What you've got to acknowledge is each device, all right, on the network has a unique ID / physical address. Now I'm going to demonstrate that now with and show you how to get to that, alright? If you go to, alright, on your phone, say for example you are on an iPhone here, if you want to see what that device is, that MAC address number, I'm not going to give you my MAC address for security reasons, but when you go into the general settings and go to About, if you scroll down, what you should be able to see is your Wi-Fi address, MAC address, and your Bluetooth. So each part has its own MAC address, and what you can do is you can filter that. So each device on the network has a unique ID / physical address. There is, alright, so you're not allowed to say whitelist or blacklist anymore on the AQA spec. They have removed that term. But what you can say is there is an allow list, or you may have said a denied list. Yeah? If your device is on the allow list, you may access the network. Generally speaking here, there are only 2 marks available, but this could easily be a 3 or 4 marker, alright? But basically acknowledge that there is one device, it has a physical address, it's either on an allow or a deny list, and if your device is on the allow list, you may access the network. So just make sure you are fully aware that this is different, alright? MAC address filtering is different to a firewall. Do not get it twisted, do not get them mixed up. MAC address filtering is about filtering out a specific device, whereas firewalls generally look at rules passing through the networks, passing through the ports to see whether something is out of character or not, alright? So there are different layers, okay, on the network. The application layer and the internet layer are 2 of the layers of the 4-layer TCP/IP model. Describe the roles of each of the 4 layers. In your answer, you should name the state of the names, alright, of the 2 other layers. So it's talked about the internet layer here and the application layer. That means it doesn't want you to talk about those. Don't go and start talking about those just because you see the name. Read the question properly. It wanted you to talk about the other layers. Now the other layers that were available were the transport link, alright, and the link layer. So it wants you to go into detail explaining how these work, alright? So the application layer and the internet layer are 2 layers in the 4-layer model. Describe the roles of each of the 4 layers in the TCP model. In your answer, you should also state the names of the other 2 layers. So, sorry, I read that wrong for a second then, alright? So it does want you to talk about the application layer. So we're going to go for application. But it wants you to refer to the other layers. That's what it's saying. So application and internet. Now, the application layer is where network applications operate on this level. And these will probably be the weakest questions, if I'm honest, remembering how the layers all link together. So at the application layer, all right, this is the network. This is where the network applications work. Okay, it could be email. It could be looking at the web browser. This is where all of that happens. Okay, all right. What happens is the transport layer sets up communication between the 2 hosts. So it's establishing a connection. You've got, all right, you've got computer 1, all right, and computer 2. But what the transport layer does, so you can visualize it, is it establishes a connection. All right, so transport, the connection's now been established between the 2 hosts. Okay, what the transport layer does is it now splits it up into lots of packets. All right, so I'm just going to say transport splits data into packets, and the internet layer adds the IP address to each packet. Right? So at the internet, so we've got the transport layer, it's made it into lots of little packets, but then what happens is, all right, the internet layer adds an IP to each of those packets. All right, so it knows who it's come from and where it's going. All right. Once it's done that, it routes them across the internet. So off they go. Obviously, that would be going to computer 2, but it would take the most effective route. Alright, so the internet layer sends the packets across the network where the link layer makes sure it is translated using the device driver. Best way to visualize that is every computer has an NIC, a network interface card. That's where all those packets are kind of put back together, all the information's translated, okay? So you've got your 4 links, the application layer, the transport layer, the internet layer, and the link layer, okay? And what happens there is then when it goes back to the next computer, it goes in the reversed order, okay? So what you've got to remember is that the network interface card is in charge of translating and compiling and putting all of those packets back together. All right? All right, question 5. What's the purpose of the internet layer within the TCP stack? Well, it either packages or unpackages the data, right? So it either puts it, all right, back together, or it takes it apart for and after transmission, okay? So it either packages the data or unpackages it, all right? So think about it. It's adding the IP address before it goes off, but actually when it's arrived, it's getting the IP address of where it's come from and getting the order that it goes back into. Does that make sense? Yeah? It depends on the end, whether you've received it or whether you've sent it. So it adds the address, if you didn't have that, routes packets across the network. Obviously this is only 2 marks, but you could have a 4 marker on this. But it also provides error checking. If, for example, you only get, say, 7 out of the 9 packets, then it's going to, or one of those packets is corrupted, that's where it will then go, oh, can we request another packet again? That's why sometimes when you see the download progress bar, it might hang at, like, say, 60% for a long time, and then all of a sudden speed up again because it keeps requesting the one packet that didn't go through. That's kind of a visual way to help you remember that, all right? So it's got error checking built into it as well, all right? Now, go on to 6. Discuss the advantages and disadvantages of connecting a computer to a network. Now, there's obviously pros and cons here, but you've got to make sure you split your answer. Don't obviously write it like this, but I'm going to do it to help you visualize it, okay? So I'm going to say the pros and the cons. One of the pros of connecting to a network is you can actually share devices, which saves money. For example, that one printer in the room. Could you imagine if you weren't on the network, you are going to have a single printer for every computer in the room. All right? So a pro, sharing devices, all right, or sharing files is easier. Sharing devices is cost effective, i.e. printer. Con, if you are not on a network, well, it says con of connecting, right? So a bad thing is you are more open to attack, okay? You're open to attack from external, you could say hackers, yeah? The other thing is, by going onto a network, you're more likely to spread a virus if it's on a network. Obviously, I would like you to structure your answer in paragraphs. I'm just giving you examples here, all right? By being on a network, you can work in multiple locations. Work in multiple locations. So you can be anywhere, all right? You can actually, by being on a network, do backups a lot easier. They're easier to maintain. All right. You can enable web services, which means, like, for example, you could maybe have create an email communication system throughout your business that only your business employees can access. So by having a network, that's a really good thing. Problem about having a network is it can cost more on hardware, meaning your business have some really expensive upfront costs. All right, you may have to employ more people, more technical support to keep the network up and running. Well, I'm going to say network up and running because I don't like it when people write it. Keep the network up and running. All right. If there is a hardware failure, on the switch, on a main component like a switch or a router, the whole network, or section, I guess, / section of network goes down. But in order to get your 3 marks, you need to have a balanced opinion there. You can't just go all in one area and talk all about the pros and just leave it at that. All right? Especially for a 6 marker, what you're looking for a mark in the high range, you're looking for at least 2 from each. Okay? For a 6 marker, you're looking for at least 2. So that's going up to 9. What do you think you're going to have to do? 3. You would have to do 3, but make sure you link it back to the context. Alright? So generally speaking, when you have a longer essay style questions, they will give you some more context up here, like somebody is a software developer or somebody is a video editor, and then you would link these back. So for example, if I was talking about backups, I'll be talking about backups of high video files, yeah? Or if I was an animator, I might be talking about how the cost of hardware might make it so that I can't employ, say, another graphic designer in my company. So you just got to try and find loose links to the context of the question to make sure you're writing that. This question I know I've done before. Define the term protocol. I'm pretty sure I've done this question with you in the past, all right? But remember, the term protocol, there's 2 marks. First mark is always for saying a set of rules. All right? 1 mark for saying it's a set of rules. just always think, always remember, all right, that in school you have protocols to follow, and if you can remember the term protocol as rules, like a protocol for you is to hand homework in on time, a protocol for you is to turn up with your equipment, a protocol for you is to wear your uniform. So a protocol is a set of rules for the network. Alright, now here's where the second mark, to allow two or more computers to communicate. Alright, we are now, I'm just looking at the time, we are running short on time, so what I'll do is I'll do a separate recording for this one in case I run out of time, but I'll do the separate recording with the other group. No, we should actually, rather than me handwrite this, because it is an essay style question, I will finish this one. So list 3 different measures that can be used to maintain the security of a network. So there are 9 marks available for this, but really what you need to do is have 3 different measures and make sure you've mentioned 2 things about each of them in lots of detail, because you've also got to put measures. So let's have a look at these. There's lots of different ones here. Alright, so I'm just going to summarize these for you. A virus checker. You've got to show, this is where your understanding marks come in, that you understand that it scans the files to look for malicious code. You need to also understand that a virus checker, because you usually get a theory question about how virus checkers work, they check the virus definition against a database. If that database is not up to date, you leave yourself susceptible to getting new viruses. Alright? But the good thing about virus scanners is you can quarantine, delete suspicious files, and it's effective against malware such as worms, trojans, that sort of thing, okay? And do not say Trojan horse this time in your exam, please. Alright? Firewalls. They analyze and scan network traffic to see whether it meets the rules to be allowed inside your network. It can block suspicious hosts, so it might be that there are certain ports that you are not allowed on your network, okay? We know that port 8080 is HTTP, which is what we access websites on, but it might be that there's a port, I'm just going to throw a random port out there, 90, that is often used for somebody to hack, so the school blocks it. So you've got to be aware that firewalls can control what traffic is allowed in and out the network by checking it against certain rules, okay? You may have biometric systems that check the username and password to make sure things are authenticated. Alright, I know that library systems often in school have a thumbprint that use your biometrics, okay? But there is always a authentication system in school. You have a username and password, alright? By putting one of those on, alright, you can stop and prevent hackers and unauthorized accessing. We have already talked about MAC address filtering and how there is an allow and a disallow list. So remember, we don't say white list or black list anymore. We say allow or disallow list, all right? Get in the habit of saying that, all right? Each hardware device has a unique address. We've already gone over this, so I'm not going to go over that one too much. Encryption, there will be data stored and transmitted as ciphertext, so basically that means it's the coded form. Remember how we've talked about the Caesar shift in the past, where you shift it by 3 letters, alright? So that's your ciphertext. When it goes into ciphertext, it's sent all jumbled up, alright? Only the person with the correct key on the other side can get that information, alright? But encryption's really good to stop people from stealing your data or listening in on what you're doing so that they can't get too much information from the system, okay? There is also, as in our school network, we do not allow you to bring in memory sticks. You are not allowed to bring in memory sticks, and the reason for this is it stops you bringing in any viruses you may have on your home computer. Also stops theft of data. So I can't put a memory stick into my school laptop and steal all of your personal information. All right, so that's the idea of that. Access rights. We have access rights on certain privileges, like I'm allowed access to more network resources than you because I'm deemed to be more responsible because I'm your computer science teacher. So I'll be allowed access to certain things that you're not, like your registers and personal data. You're only allowed access to your data, but I'm allowed access to more so I can contact your parents if I need to. So it's effective against hackers, theft of data, and unauthorized things. Captures are really good for websites when they check whether it's a robot or not. Generally, concert websites might use that to stop people from multi-buying tickets all at once. It still happens, but the idea is that it detects whether your click is like that of a human being or detects that you can read what's on the screen. So humans do certain tasks differently, and the way you hold your mouse on the screen is different to the way that a robot would do that. But it's effective against hacking and bots, but obviously we also then have our updates that are used to stop hackers from, getting through those little loopholes there in the network, okay? So hopefully that goes through networks a little bit for you to prepare you for some of those questions. All right.